Hi all, welcome to operating system course. So in the last class we had studied till resource allocation graph. So today we'll be getting started with methods for handling the deadlocks. So we can deal with the deadlock problem in one of the three ways. So the three ways are: the first one, we can use a protocol to prevent or avoid deadlocks, ensuring that the system will never enter a deadlock state. So we have to make sure the protocol, whatever we are using, so that protocol it prevents or avoids the deadlocks. The second one, we can allow the system to enter in a deadlock state, then allow the system to detect the deadlock, then get recovered from the deadlock. The third one is we can altogether ignore the problem and pretend that the deadlock has never occurred in the system. The third solution is one which is used by most operating systems, including your Unix and Windows. It is then up to the application developer to write the programs that handle these deadlocks. To ensure that the deadlocks will never occur, the system can either use two methods or two schemes. One is deadlock prevention, or it can also use deadlock avoidance. One of these has to be used by the system. Okay, so first we'll talk about the deadlock prevention. So in the necessary conditions for the deadlocks to occur, we had seen four things, right? Mutual exclusion, hold and wait, no preemption, and circular wait. So whenever these four things occur simultaneously, we say that deadlock has been occurred. Okay. Now, whenever one of these necessary condition is not satisfied, so in that case we can prevent the occurrence of deadlock. So the first one is mutual exclusion. So in the mutual exclusion condition, it must hold good for non-shareable resource. Say for example, you have a printer and that particular printer cannot be shared simultaneously by or between several processes. So if you have shareable resource, say suppose for example you have a read-only file. So it is a good example of shareable resource. So whenever multiple processes access that or open that shareable resource, which is a read-only file, there is no problem at all. So at the same time, we can simultaneously allow multiple processes to access that read-only file, which is a shared resource. So a process never needs to wait for a shareable resource. So however, we cannot prevent the deadlocks by just denying the mutual exclusion condition, because some resources are intrinsically they are non-shareable. Okay. So the next condition is hold and wait. So to ensure that the hold and wait condition it never occurs in the system, we must guarantee that whenever a process requests a resource, it should not hold any other resource. Basically, what is hold and wait? When does this how does this occur? So hold and wait is nothing but whenever a process is holding a resource and it is waiting for some more resource or some other resource which is being already held by another process. At that time your hold and wait condition occurs, right? So in the deadlock prevention method, we should ensure that this hold and wait, we have to break this hold. So how can we ensure this hold and wait never occurs? So one protocol that can be used, it requires each process to request and be allocated all the resources before its execution. So this means, say suppose you have a process P1 and it requires 5 resources. Okay, say example printer and CPU, some other thing, all 5 resources it needs. So what can be done is like, so whenever that process P1 it requires those 5 resources, at the beginning of its execution only, that process P1 it has to request all these resources. Okay, and whenever all these resources are free, that has to be allocated to its to that particular process. So after that only your process can start its execution. So even if one of the resources is not available, your process cannot start its execution. So an alternative protocol is that it allows a process to request the resources only when the process has no resources. A process may request some resources and use them. Before it can request any additional resources, it must make sure that all the resources which it has just used, it must ensure all these resources are released so that the new resources can be allocated to the process. So by using these two things, we can make sure this hold and wait condition, it never occurs. So let's take an example and understand this one. Okay. So consider you have a process that copies data from a DVD to a file. Okay. So you have you have a process, it copies some data from your DVD drive to the file which is on the disk. After that, it sorts the file and then it prints the result to the printer. So if all the request, suppose if you are following the first protocol, then what should be done? So all the resources must be requested at the beginning of the process. Then the process, what it has to do, it must initially request for your DVD drive. It wants disk file and the printer. So all these resources must be allocated to the process at the beginning or before its execution. Once all these things are available, then only the execution of that process can be started. The second method, what it does, it allows the process to initially request the DVD drive and the disk file. So once it has copied the data from the DVD drive to the disk, it releases both the DVD drive and the disk file. Okay. Now the process must again then request for the disk file and the printer. So after copying the disk file to the printer, it releases these two resources and then it terminates. Again, these two protocols, they have disadvantages. The first one is resource utilization may be low. Why? Because we are using resources that may be allocated but unused for the long time. So in the example, just now we have taken an example, right? So for example, we release the DVD drive and the disk file and then again request the disk file and the printer. Only if we can make sure that our data will remain on the disk file, then we can again, access for the disk file. Otherwise, we must request all the resources at the beginning of both the protocols. So the second disadvantage could be here is the starvation. That is, the process that needs several popular resources, it may have to wait indefinitely because at least one of the resources that the process needs is always allocated to some other resource. So these two are the disadvantages of this particular hold and wait in deadlock prevention. So the next one is no preemption. So no preemption means you cannot forcefully take the resources from your processes. So to ensure that this condition, no preemption, it does not hold good, we can make use of this particular protocol. That is, if a process is holding some resources and it is requesting other resources that cannot be immediately allocated to it, then all the resources that particular process is currently holding are preempted. So in the necessary conditions we had seen no preemption, right? That means you cannot forcefully take back the resources from the process. But to make this condition false, what we can do, we can preempt. That means we have to forcefully take back the resource from the processes. So these resources are implicitly released. That means the preempted resources are added to a list of resources for which the process is waiting. The process will be restarted only when it can regain its old resources as well as the new ones that it is requesting. Say for example, you have a process P which is currently holding resources R1 and R2. Okay, so resource R1 and R2 are currently being held by process P, and now P is requesting another resource, that is R3. Okay, so it is known that R3 is not, it cannot be immediately allocated to this process. Then what can be done is like, so this already holding, the process is already holding resource R1 and R2. At that time, these two resources have to be preempted. These two resources have to be forcefully taken back from the process P and they should be put in the list of resources which the process is waiting. Like it is waiting for R3, then again R1 and R2. So it has to be put in a list. So say after some time again your process P has requested this R3, R1 and R2 resources and all these are allocated to it. At that time what it can do is like it can start its execution. Okay, so right now your process P, it is not having any of the resources with it. So after some time what it can do is like again it can request R1, R2 and the new resource R3. Why R1 and R2 are old resources? Because previously it was allocated to it, but those resources got preempted, right? So only when the R1, R2 and R3 are available and that are allocated to the process P, then this process can start its execution. So the next process or the next approach is, so if a process requests some resources, first we have to check whether they are available. So if a process P, okay, is requesting R1 and R2 resource, first we have to make sure these are available. So if they are available, we can allocate those resources to the process. So if they are not available, then we have to check whether they are allocated to some other process and that is waiting for additional resource. Okay, so that means, say suppose these are not available. Okay, R2 is currently being used by P1, say suppose. Okay, so if these resources are not available, then we have to check for the resources whether they are allocated to other processes, and that process, is it waiting for any other resource apart from this resource? We have to check. Okay, so if this condition occurs, then we have to preempt the desired resources from the waiting process and we can allocate them to the requesting process. In our case, in this case, we can preempt resource R2 and that can be allocated to the process P. So if the processes are neither available or nor held by any waiting process, then the requesting process, it has to wait. In our case, say suppose your resource R2 which your process P request, it is not available and it is not also been used by some other process. In this case, what should your process P has to do is it has to wait unless and until your R2 becomes available. Okay. So the last one is circular wait. So one way to ensure that this circular wait it never holds is to impose a total ordering of all the resource types and to require that each process request the resources in an increasing order of enumeration. So we'll take an example and we'll understand how this circular wait can be broken. Say suppose we have a set of resources that is R1, R2 up to Rm. So we assign to each resource type a unique integer number. So resource R1 means the integer number 1, R2 means 2, something like this. We will assign a unique integer number to the resource types. So this, whenever you allocate these numbers, integer numbers to the resource type, what it does is like it allows us to compare two resources and to determine whether one precedes another in our increasing order, whether 2 is preceding 1 or 3 is preceding 2. So this can be checked whenever we give the unique integer number to the resource type. So we define one-to-one function, that is here function R to n. So this means n is your integer or set of natural numbers. Say example, if the set of resource R it has or it includes tape drives, disk drives and printers, then your function, the function f might be defined as f of tape drive is equal to 1, f of disk drive is equal to 5, f of printer is equal to 12. So in the circular wait, whenever you want to break the chain or this circular wait, you have to ensure that you are giving a unique integer number to your resource types and then you can compare the numbers. So you can compare the two resources and then you determine which one precedes the other. So in this case, in this way, we can cut the chain of the circular wait. That's it for today. We'll conclude our session. Thank you.